So let's start with tetrahedral carbon to get the basis of these differences. Tetrahedral carbon, when there are 2 or 3 of the groups that are the same, we can rotate that around and it's the same as its mirror image. So take a look at this first one right here. 3 groups are the same, the 4th is different. I can reflect that in the mirror, but it's just going to be the same as the original molecule. Okay? If you were holding this one right here and looking at it in the mirror, they would look like the same molecule. The same thing can happen even if I have 2 groups that are the same. Why? Because I can rotate that just a little bit and get those same 2 groups in the place that they were originally. So I did a reflection, but I can twist that around. Right? I brought this one over here, I brought that one over there, and that's now the same as the original. However, if I have all 4 groups that are different, the mirror image will be fundamentally different from the original molecule, and there's no way I can twist that around in order to make it the same. Here, for instance, are 2 mirror image molecules. If I tried to superimpose them, 2 of the groups will match, but 2 of the groups will mismatch. I could try to rotate it around again to get the other 2 groups matching, but then the remaining groups will mismatch. I have some 3-dimensional models that I've linked to on the web page that if you don't have access to a model kit, take a look at some of these and they'll help you out. If you do have access to a model kit, it's just as simple as putting 4 different colored atoms on a carbon and looking at it. But if I take a look at these 2 molecules, they are obviously mirror images. The purples are towards each other. Okay? Greens are going up, white coming towards you, red going back. I can rotate one of these around here, but I can never get it to look the same as that one. Right? If I match up purple and green, then red and white are switched around. If I try to match up red and white, like that, then purple and green are switched around. There's nothing I can do to get everything to match up with each other. Here, let me try to match up red and purple, for instance. Yeah, then green and white are switched. So they're mirror images of each other, as we can hopefully see. There you can see they're mirror images of each other like that. But there's nothing that I can do to make those superimpose with each other. When that happens, those 2 non-superimposable mirror images are called enantiomers of each other. So when you have a pair of molecules, that pair is enantiomers when they're mirror images, but they're different from each other. They're not identical. So enantiomers are a relationship like brothers. You cannot have just one molecule and say it's an enantiomer. You have to be comparing a pair of mirror image molecules. One way of indicating each enantiomer is the use of a plus and a minus sign, and we'll talk about what they mean in a moment. But plus lactic acid and minus lactic acid are mirror images of each other that cannot superimpose. They are enantiomers, and I'll show you the structure of those in a few minutes.